November. Welcome everyone to day 6 of November to Remember series of talks. As it was mentioned earlier, we're in the third edition of this series, and the theme for this series is tech transformation, shaping the future of society, education, and industry. And today, the tech leader that will be leading today's session will be Jyotika Athavale. She's the Director RAS Architecture Synopsis, and she's also the President of IEEE Computer Society. Now, today she'll be talking about functional safety interoperability for automotive use cases, and I'll now read a brief bio about her. Jyotika is a Director, Engineering Architecture Synopsis, leading quality, reliability, and safety research, pathfinding, standards, and architectures for data centers and automotive applications. Prior to Synopsis, she was the lead technologist, functional safety architecture at NVIDIA. Prior to NVIDIA, Jyotika was principal engineer, director at Intel Corporation, leading corporate-wide RAS and functional safety architectures. Jyotika also serves as the 2024 president of the Global IEEE Computer Society, overseeing overall IEEE CS computer science programs and operations. She leads and influences several international standardization initiatives in the area of RAS/safety in IEEE, ISO, SAE, IEC, JEDEC, and OCP. Jyotika led the development of the IEEE 2851 2023 standard on functional safety data format for interoperability. She now chairs the IEEE P2851.1 standardization initiative on functional safety interoperability with reliability. For her leadership in international safety standardization, Jyotika was awarded the 2023 IEEE SA Standards Medallion. And for her leadership in service, she was awarded the IEEE Computer Society Golden Core Award in 2022. In 2024, Jyotika was awarded the IEEE Women in Technology and Leadership Award for outstanding contributions to engineering and technology, the empowerment of diverse populations, and the advancement of women in STEM. Jyotika co-founded the IEEE RAS in Data Center Summit and the IEEE RAS in Automotive Summit. She also serves as the chair of the 2025-2026 IEEE Women in Engineering International Leadership Conference. Jyotika is an appointed member, industrial expert of the Board of Studies for the Department of Computer Engineering and Information Technology at DGTI, Mumbai. She is also recognized as a distinguished alumna by the same university, her alma mater. She has authored patents and many technical publications in various international conferences and journals. Jyotika has also pioneered and chaired international workshops and conferences in the field of dependable technologies. So everyone, please let's welcome Jyotika Athavale.
Thank you so very much for that kind introduction. And first of all, I wanted to express my deepest congratulations and gratitude to Celestine and all of you for organizing these series of talks. They are very valuable, and the level of engagement in the community is really outstanding. So thank you very much for your efforts. I will go ahead and share my slides. Okay. So let me know if you see my screen.
Yes.
Yes, we can see your screen.
Okay, perfect. Great. Thanks a lot. So the topic that I wanted to cover today was on automotive functional safety and RAS, and I wanted to share a little bit about what we are doing for standards development. Oops, sorry. For standards development in the area of functional safety. Before I dive into that, I have a few slides sharing a little bit about the Computer Society as a whole, an overview of what the Computer Society's mission is, what are the various program board activities, etc. And just to kind of preface this standardization work that is happening in functional safety and where it resides within the computer society. So as you all probably are aware, that there are many technical societies within IEEE under the IEEE tab or Technical Advisory Board umbrella. The Computer Society is the largest society among all of those societies, and it has a very large scope and breadth of topics and technologies related to computing. And we also have very many different activities. So uh, my pathway to in IEEE and the Computer Society was primarily through standards. Also now I'm engaging in other activities, as president, covering conferences and publications and educational activities, chapter activities. But standards was one of my key areas of focus. And this work on IEEE P2851, which is the project that I'll talk about today, was kicked off in the approval actually happened in 2019, late 2019, and then the working group was kicked off in early 2020. And so last year we published the first standard in P2851. It's the 2851-2023. And that was on dependability life cycle and identifying topics for functional safety interoperability. And now, because P2851 is a family of standards, the working group is now working on the derivative standard or the first dot standard in the series, which is on addressing functional safety interoperability with reliability. And as you know, functional safety is one of the key technologies for safety critical systems, automotive being one of the key application domains where functional safety compliance is critical. So that's kind of just a quick introduction on the standard. But with respect to computer society, and some of you may or may not have seen the slide, but just shows our scope of the various geos that we cover under the Computer Society umbrella. We have a global reach of over 375,000 community members, 168 countries, and 654 global chapters, 30 technical communities, 21 special technical communities. So Computer Society has been in existence for over 75 years. Personally, I joined the Computer Society ever since I, graduated from college, and I've been a member since then in various different activities in authoring papers, serving as a technical committee reviewer in conferences, working on standards development. And really, I mean, my advice is to consider, tying yourself to one of the technical communities. There are many different technical communities which are organized by technology. So based on the technology that you're interested in, you can connect with one of those technical communities, which is the focal point for all of the activities for that particular technology, whether it's conferences, standards, publications, etc. So here's that list of all of those different technical communities. As you can see, we have that technical breadth as well as the depth. And these, each technical community has its own roadmap for the different, different conferences, standards, and other activities that are within its umbrella. So, it will then organize the implementation or the execution of those, roadmap activities, and also will discuss incubation or new activities that are um, that are to be considered within the scope of that specific technology. So here's that list of all of the different ones that are under the Computer Society umbrella. The one that I'll talk about is related to, dependable computing and fault tolerance. When we talk about dependable computing, we are referring to all of the technologies that are under the spectrum of dependability, which covers functional safety, reliability, availability, maintainability, cybersecurity, real time, and SORIF, which is safety of the intended functionality. So the term RAS is used, to cover some of these dependable technologies. So RAS stands for reliability, availability, serviceability, and so it's kind of goes hand in hand with the dependable technologies. So as you also know, one of the big focus areas for the Computer Society is publication. So this talks about just the number of papers and articles and publications that we have in our, digital library, both in terms of magazines as well as technical journals. And we have the list of those here on the next page. Many of you may be receiving the computer magazine regularly. It's our flagship magazine. But then we have many other magazines on other topics like computing and science and engineering, or computer graphics, intelligent systems, etc., security and privacy. And then here's a list of all of our transactions, our letters, and our open access journal as well. So these are all, very prestigious, uh, ways in which you can publish your work. So I highly encourage you to submit, your contribution for consideration, in these publications that we have, and we do these periodically. We have, different editors for different columns within each of these magazines, and they are very happy to receive submissions and include them in our future magazines and journals. Conferences is one of the main focus areas, or one of the key revenue generators for the Computer Society, but is also one of the key value propositions for industry. So I've been working in industry for over 25 years, and the companies that I've been with, they see, one of the key values of being connected or being a member with the Computer Society is the ability to participate in these conferences, either as a speaker or as a participant, but just the value in learning and networking, and making new connections, finding mentorship, finding new solutions for the challenges that we are working on, for the problems that we are working on. So there's huge value in that. And so we have our conferences attended by over, as we know, we have close to 200 conferences, and we have our conferences attended by over 65,000 people each year. New conferences are continuously born. For example, this year we introduced two new summits. Those were inaugurated. One in June that was on RAS and data centers, and the next one will be held next month in December, and that's RAS and Automotive. So we'll, again, be on that reliability, availability, serviceability topic, which is so important today in the industry across application domains. And so the RAS summit that we had in June was very successful. We had a huge participation from industry. There were a lot of great discussions on various topics related to data centers, and a lot of interest in seeing that continue. So looking forward to this next one, this next summit on RAS and Automotive next month. And then we talk about standards. So, as I mentioned, this was one of my key areas of focus in the Computer Society, and IEEE was, my work on standards. This shows the number of standards in the past year. We had 28 new standards, 217 active standards currently within Computer Society, and that, number continues to grow, because especially in the new technologies that are, advancing quickly, such as AI. And so in the Artificial Intelligence Standards Committee, we've seen a lot of new projects being submitted, new working groups initiated, and new study groups being formed. But that isn't just that's not just limited to the AI Standards Committee. There are all of these other standards committees where there is a lot of activity happening, including technologies like you can see here, blockchain, cloud computing, cybersecurity. The one that I'm involved in and where P2851 resides is in the Functional Safety Standards Committee. This one was created in 2021. And so there are multiple working groups, study groups, and various activities happening here. There's the IEEE 802 standards, which we are very proud of. The work that they have done, and this resides within the Computer Society, and then a lot of other different technologies. So this is just within Computer Society. Wanted to mention that all of this work of standards development in IEEE is managed by the IEEE Standards Association, which provides that oversight, staff support, the policies and procedures for standards development, and all of the guidance. There are other societies within IEEE that also sponsor standards development for their specific domain, like for example, the Reliability Society has their standards, the Vehicular Technology Society has their standards development, and so on. So each society is sponsoring specific committees, and this is the list of the committees under which there's now multiple working groups, which are developing standards on various different topics, like the P2851 is one of those working groups. And then I wanted to share with you this work that happens for technology predictions under the Computer Society umbrella as well. So the Computer Society started this work on technology predictions a few years ago, which is a really important activity because the output of this is a report that lists and ranks and prioritizes the top technologies based on certain criteria, which includes the impact of that technology, the maturity of that technology in a given year, as well as the impact to humanity. And that ranking and scoring and grading is done by a list of experts in various technological domains across industry, across academia, and across government who come together and co-author that report. And then we publish that report on the Computer Society website, and it can be downloaded for free. But the reason that's also important is very strategic, because that roadmap serves as the guide to all of our program board activities. So based on the specific technologies that we identify in that report, we can then plan our future activities, our future conferences, future standards, and publications that are specific to that technology. So maybe introduce new standards committees, introduce new conferences, etc., based on that guidance from that report. So we really value it. We grade it at the end of the year. And then there's also mega trends that are created by the IEEE Future Directions Committee based on this technology predictions report. So then jumping on to P2851 specifically, this is the standards committee that I chair. As I was mentioning, this is on functional safety and interoperability for autonomous systems, for safety critical systems. And this work, this family of standards, addresses a known problem related to interoperability for functional safety. So for functional safety, we do have many different standards, that are being developed by different SDOs or different standards development organizations. Several of those are governing standards for a given application domain. So for example, for automotive, we have the ISO 26262, which is considered a governing standard. We have the IEC 61508 for industrial, and we have DO 254, DO 178C for avionics. So these are governing standards that have, normative requirements that a given safety critical system needs to comply with. Where IEEE plays an important role is in terms of interoperability and support. So I'll talk about what we mean by interoperability in these slides, but basically what P2851 is doing is providing implementation guidance in terms of methodologies, tools, description languages, data models, and databases for for the safety engineering community, such that they can, uh, execute their safety engineering work to comply with those normative requirements and the governing standards. So our first standard on 2051, which was published last year, is called the Standard for Functional Safety Data Format for Interoperability within the Dependability Life Cycle. Now we are working with regulatory and OEMs to drive adoption of the requirements and the content that was included in that standard. So this year we kicked off our first dot standard or derivative standard, which is the IEEE P2851.1, which what this standard is doing is it's looking at the topics that were identified in the base standard, where interoperability is a gap or challenge, and then it is providing implementation guidance for those topics. So this first one, the dot one, is looking at the most critical topics that were identified for functional safety interoperability with reliability, and there's like 5 of them. I'll talk about those topics later in this presentation. And the dot two is a new PAR, which is just being proposed, and that will cover the intersection of functional safety and cybersecurity. Okay, so when we talk about interoperability, these are the 3 kinds of interoperability that P2851 family of standards is considering in scope. So the one is the interoperability across levels, meaning traversing from IP to SOC to system to item. So this is the V model from ISO 26262, which shows all of the safety engineering activities from concept, design, all the way through verification, validation, integration, and production. And for each activity, there are certain methodologies and tools that are executed by the safety engineer. However, the way in which that activities, or the methodology by which the activity is executed, the format in which the results are reported in the work products, the tools that are being used for the execution, and the data model, all of that is not standardized today, right? So each company across the value chain is doing that implementation in their own way, in their own custom way. So in order to ease that data exchange, when we integrate safety analysis data from IP to SOC to system to item, to streamline that integration of data, to reduce cost, reduce resources, reduce time and overhead, and speed up the time to market. This is what a common data format would provide. So this is the reason or motivation for having the interoperability across the levels. The other one is the interoperability across the technologies. So as we mentioned, under the dependability umbrella, we have functional safety, but then we also have these other adjacent technologies like reliability, like cybersecurity, like real time. And so in order to have this interoperability, what we are doing is during each one of these steps, we iterate and do an optimization or trade-off to consider the requirements that are from these adjacent technologies that are relevant to functional safety. And so we do those trade-offs and optimizations and iterate, so we have that holistic view, because if we do that in a vacuum or in a void without considering those implications from the adjacent technologies, then we may execute a solution which is conflicting with a requirement from one of these adjacent technologies. So it's important to do that handshake at each step as we execute, and that's this second type of interoperability. The third type of interoperability is looking at the data exchange across the application domain boundaries. So considering, you know, the reuse model, considering where we may execute our safety engineering activities to a governing standard like the ISO 26262 for automotive, and we generate a set of work products, and if we want to reuse that for another safety critical domain like industrial or avionics, without having this common framework for the methodology, for the data model, the description language, this exchange of data across the boundaries will not be possible. The reuse of data from automotive to industrial or avionics will not be possible. So it will not be easy, or I guess will be challenging to do that. So in order to ease that, IEEE P2851 serves as the glue to connect these application domains and streamline that data exchange across the application domains. And so in the annex of the base standard, the IEEE 2051-2023, we'll find this this figure which introduces the notion of the dependability life cycle. So when that word dependability being this umbrella term, in this case, in the case of 2851, when we define dependability, we are looking at functional safety as kind of the core, and then looking at the interaction of these other adjacent technologies relative to functional safety. And then, as we looked at on the previous slide, iterating across that V model for each activity as we, execute the safety engineering work and develop the work products, we consider this iteration across these dependable technologies in that work. So in the standard, we have defined that life cycle with the different phases, all the way from concept through production and post-production. And then within each phase, we define the list of different activities and topics where interoperability is a gap or challenge. And then we highlight which technologies are in scope of that specific activity or topic, and what levels are relevant, and what kind of problem we need to address with respect to interoperability. What is the proposed solution that can address that? And then those are the solutions that we are now working on implementing in the DOT standards. This is another figure from the annex of that base standards, which is the dual cone V model. So inspired by the V model in ISO 26262, this dual cone V model shows, the different systems and subsystems where interoperability is in scope in P2851. So starting hardware, software components, SoC, subsystem, E system, network, and then the overall system and the operational domain. So interoperability is being considered across all of these levels, and within, each one of these circles, in this cone, in this dual cone, you see the concentric circles represent each one of the various dependable technologies that we are considering. So we execute across the levels, considering all of these dependable technologies at each level, and that's done across, all of the phases of development. So when we kicked off the working group in 2020, we also split up into 6 different subgroups, and each subgroup focused on identifying the key topics and needs that are in scope of their subgroup. So the subgroups were split up into these 6 different topics: automotive, AI safety, cybersecurity, AI safety, cybersecurity, avionics, industrial, medical, and SOTIF. And then collectively, when we combined all of the needs or topics identified by each one of the subgroups, we came up with a list of over 100 needs. And each one of those needs was then organized in this kind of format, as you can see on the right, with the description of what is the problem statement, what are we trying to do, the title, what is the proposed solution, what are the limitations, what levels are applicable, what are the references. And so all these tables can be found in the annex of the P2851 base standard. And then corresponding to each one of these in the main body of the base standard is a normative requirement, which states what is the interoperability that needs to be considered for this specific topic. So overall, in P2851 in the committee, we have over 30 companies. These include IP/IC providers, EDA vendors, tier ones, and OEMs. And so that membership is continuing to grow as we are, implementing our DOT standards. Here's an example of some of the needs and topics when we talk about these interoperability challenges tied to a particular topic. As I mentioned, there were over 100 needs that were identified, and here are examples of some of those. So all of those needs were organized or bucketed into 3 different buckets, and that's description language, methodology, and database. So here's examples of some of those topics, like, for example, what is the methodology for doing ASIL decomposition or for calculating vulnerability factors? Or what is the description language for base failure rate, which is the reliability failure rate that feeds the safety analysis? What's the database for AI training data sets? What are the parameters we need to monitor and measure for predictive maintenance or prognostic? So here's just kind of a flavor of some of those needs that we collected to give you an idea of the kinds of topics in scope. And then this is kind of a eye chart, but this is another informational flow chart that was included in the annex of the base standard to give you an example of how we look at alignment across the technology. So this is looking at functional safety and cybersecurity alignment. And so there's a flow chart included in the annex which shows the different activities executed in functional safety, like what you're seeing here in purple, and then in cybersecurity here in green, and it shows the handshake across the different steps across that flow chart. So for example, you're doing the hazard and risk analysis in functional safety. Correspondingly, you do the threat and risk analysis in cybersecurity, and then you do a handshake or feed that information over here. You do this safety analysis based on technical safety concept here in the functional safety flow chart, and then correspondingly you have the vulnerability analysis and those impacts or implications. So it shows how you consider the output of each one of those phases as you're executing in tandem the functional safety and cybersecurity activities. With respect to our roadmap, so, we're done with this one. We'll start planning shortly on the Rev 1. So this is the base standard swim lane. And so we'll do a revision to that base standard every few years. And then here's the dot standard swim lane. So, we are currently developing the P2851.1 on FUSA reliability. We are about to kick off the P2851.2 on FUSA cybersecurity. And then at a later date, we will also have the dot 3 and dot 4, considering other technologies like SOTIF and real time. With respect to P2851.1, so here's the list of topics that we are currently implementing in that standard. So we have 5 topics. The radiation testing for soft errors, so looking at system level requirements for radiation testing for functional safety. How do you model and measure vulnerability factors like architectural vulnerability, time vulnerability, program vulnerability? how do you estimate methodology for estimating base failure rate? This was important because the previous standard, the IEC 62380 for base failure rate estimation, has end of life, and so the functional safety community is looking for a new way to calculate the base failure rate. System RAS architecture is another important one, and then the prognostics activities or predictive maintenance, which is another hot topic today. And so all of these are being worked by different topic groups. So right now for P2851.1, we have 5 topic groups, and each one is working on their specific implementation. And then the dot 2, which, as I mentioned, we are just about to kick off, is on functional safety interoperability with cybersecurity, and we're still working on the list of topics that we will implement on that. But here's some suggested topics that may be in scope, still not decided, but they could be software architectural design, methodology, description language, safety assessment for software updates, methodology for that, and then methodology for doing confirmation reviews. That was it. So that was my last slide. I just wanted to thank you all once again for participating, for organizing, and like to congratulate you for the series and keep up the great work. Thanks a lot, and I'm happy to take any questions.
Thank you, Jyotika. That was an amazing presentation. I have one question. So I would like to know, you mentioned earlier that you joined the IEEE Computer Society. So I would like to know how much of an impact as you being a member of the IEEE Computer Society, how much of an impact has it had on your professional career?
Oh, so it's a great question. So I think that I first joined the Computer Society, as I mentioned, I was just had just graduated. So just, like as a student and then just graduated. So my motivation was to keep in touch with the new technologies, the advancements happening in various technologies to understand, where the industry was headed. And so that was the key reason why I joined initially. But then over the years, as I started doing more publishing, like publishing papers, and then also I became more involved in conferences. So I was asked to serve on various technical committees through my company. So this when I was working at Intel at the time, and so Intel was organizing conferences in the areas of reliability, and they wanted me to serve as a technical reviewer on some of their committees. So I was representing my company there. And then as I started working on functional safety, one of the key or important aspects of functional safety is compliance to standards. And so I got more involved in standards development, again, representing, Intel. And IEEE was one of the SDOs that was developing standards for CUSA, but then there were also others like ISO and IEC. And so I started participating there. And then slowly I started growing my participation. I joined NVIDIA after that in beginning of 2021. And so again, NVIDIA was heavily involved in standards development. And so, it was my participation driving or leading a standards working group was also, demonstrated leadership for NVIDIA, and they wanted to kind of lead the way in the industry, on these topics. And then, of course, in parallel, I joined the Board of Governors, and I, got elected secretary, and then later on president-elect, and now president. So that was again, showing the involvement of the company in the industry, the influence in the industry. Uh, and then later on last year joined Synopsys. Again, Synopsys is a very open company, very, very, very much involved in the community. And so the work that I continued in in standards and in conferences was directly linked to my day job, in R&D and pathfinding and those topics in my company.
Okay. Thank you, Jyotika. We have a question at the comments. Loveliana is asking, apart from IEEE, what additional training or courses have you taken to assist you in your career in standards?
Oh, so it's a great question. So I think a lot of the work I did on standard on was it on functional safety specifically, or was it on standards? Sorry.
On standards.
Ah, so standards, I didn't take any professional courses per se, other than the courses that are required by IEEE Standards Association. So IEEE SA or IEEE Standards Association has a list of classes that that participants, and some of them are required by officers. So, as an officer and then as a chair, I have to take some of those classes annually. So those are the ones which provide guidance on the standards development life cycle, the policies and procedures, the rules and the adoption, all of that. So that those are the classes that I took for standards.
Any other question? Okay, so I would like to call on Dr. Celestine Wendy to give the closing remarks uh, for the day 6th of November to remember.
Okay. Oh, thank you so much, Jyotika. We've really dealt with this topic today, because I was actually looking at the AI application to functional cybersecurity. We just got a good news like 15 minutes ago, because the EPSROC have decided to fund a cybersecurity ecosystem in UK. So, and the University of Bolton, we started it together, and so it's a very good news. When I saw the functional standard there, so in the couple of months, months to come, and with the kind of funding that we're getting, we'll be able to develop a kind of case where they want the university to be on the forefront of cybersecurity, in that it can cripple economic and also increase economy. So it's a very good news for us. Just few minutes ago that I got an email. And so we are looking at how we can use AI to make it. But nevertheless, we want to say thank you so much. I want to present our flag to you for coming. And I don't know, can everybody see this one?
Yes, we can say thank you so much, Celestine.
Okay. So we just want to say thank you for accepting this call, and we're going to send it down to you. Appreciation from the university community and the IEEE body. The person who moderated he has taken over as the IEEE president, and he's also in IEEE Computer Society as the president at the same time. So we want to say thank you again for coming, and we hope we'll continue to have this good rapport, and do big things for IEEE Computer Society and IEEE as a whole. Thank you so much.
Thanks a lot, Celestine. I'm really honored for the recognition. And in particular, I'd like to give shout out to you for, your involvement and your sincere dedication in the community, in IEEE, and in general, I think for all that you do. So really grateful for your involvement, and, for your efforts and service. Thanks a lot for that.
So much. Thank you everyone for coming. Tomorrow we'll continue. I told you this week we are going to have 3 women, because somebody was like, why are the men only speaking last week? I said this week we are going to have bombardment of the women, speaking. And the important thing is not that they are women, but they're delivering very good things. We're going to learn so much on career and what you can do to improve your CV. Tune in again 6 p.m. tomorrow as we continue in this series of November to Remember. Thank you so much, everyone, for coming. We
Thank you
appreciate
very
it.
much. Take care.
Thank you so much.